Welcome to surprising samples. So the idea here, when we're studying sampling distributions, we have samples that are to be expected, and then we have some samples that are more rare. So when studying sampling distributions, we have some sampled statistics that are typical, or some sample proportions if we're looking at those. So some sample proportions that are typical. And some that are more rare. So the question becomes, what makes a sample proportion surprising? At what point do we consider a sample proportion to be surprising? So with a normal distribution, which as long as n times p and n times 1 minus p are big enough, we know we have a normal distribution for our p hat distribution. With our mean in the center, recall when we did our 60, 95, 99.7 rule, we would hop out by copies of the standard deviation. So if we hop out by copies of the standard deviation, then if we go two hops to the right and two hops to the left, 95% of the data is supposed to fit within that window. So within two standard deviations is 95% of the data. So anything within two standard deviations we consider to be not surprising, to be essentially expected. So this is not surprising. And then anything outside those two standard deviations away from the mean, we consider to be surprising. So essentially anything more than two standard deviations away from the mean is surprising. So if we take a look at our example here, it is known that 2% of pencils produced at a certain pencil factory are flawed. The factory manager wants to know if this is still true. They pick a random sample of 500 pencils and find it has 15 flawed pencils. Is this surprising for such a sample if 2% of pencils are flawed overall? So we have 2% of pencils produced are flawed. And then we are picking a random sample of 500 pencils. So we know that our population proportion is 2%, otherwise known as 0.02. Just a reminder to go from percent to decimal form. We do 2% and then just divide by 100% to get our decimal form. Our sample size N was 500. We have a little more information here. We can figure out our sample itself. So our sample proportion p hat, we had 15 flawed out of our 500 sampled. And this winds up being 0.03. So what we first want to do is we want to study just from our population data, or from the knowledge we had before the sample. So everything here, this information, we knew before tabulating our sample results. So we know this information. Before tabulating the sample result. Versus the information I put in the box. This is specific to our sample. So when we do our sampling distribution, it's just based off of the generic information. The stuff specific to our sample only will come in when we try to figure out if that sample is surprising or not. So using the more general information, the first thing we need to do is study our sampling distribution. So in studying our sampling distribution, we need to know shape, center, and spread. So for our shape, we are looking at the p hat distribution. So we just need to check n times p. So n times p, we have 500 times 0.02, which is 10. And then n times 1 minus p, we are looking at 500 times 1 minus 0.02, or 500 times 0.98. And this should wind up being 490. Both of these are 10 or more. So we meet our requirements. So our sampling distribution is essentially normal. So the distribution is essentially normal. There's our shape. Next up, we have center. So we have mu sub p hat is just p, or mu sub p hat is 0.02, and spread. Again, I apologize for the conversations in the background if you can hear them. So sigma sub p hat, we are looking at the square root of p times 1 minus p divided by n, or the square root of 0.02 times 1 minus 0.02 divided by 500. So if we plug this into our calculator, the inside of the square root becomes 0.000392. And then once we have taken that square root, we get 0.006 approximately. From here, we have our shape, center, and spread of our sampling distribution. The next step is to figure out how our sample fits in to the sampling distribution. So where does our sample fit in to the sampling distribution? So our sampling distribution has a mean of 0.02. And then we are going up by 0.06. Sorry, 0.006. And going down by 0.006. So that becomes 0.026 for the first hop. And then after the second hop, we would be at 0.032. Going backwards, we would be at 0.014 and then 0.008. So again, we're going just 2 hops for our surprising. So anything between 0.008 and 0.032 is considered to be expected or not surprising. And then anything on the outsides more than 2 standard deviations away is considered to be surprising. Our sample had p hat was 0.03. So if we place our sample falls somewhere in here. So our sample is not surprising. So the sample proportion would not be considered surprising. If 2% of pencils were flawed in all. All right, so that is checking if we have a surprising sample.